Good morning. It's Wednesday, March 25th, and here's your warm-up for today. Yesterday we talked about compound interest, but I think it's important to still be able to distinguish between when you're figuring out compound interest and when you're figuring out just a basic exponential growth or decay function. Number one says a brand new car depreciates at a rate of 4.5% each year. If the car was worth $30,000 when it was purchased 10 years ago, how much is it worth now? So this is not a compound interest problem. This is an exponential decay problem. And the way to tell the difference basically is if you're talking about an object. If you're talking about money in a savings account, you're going to deal with compound interest. If you're talking about an object like a house, a car, or a boat, you're talking about exponential growth or exponential decay. So in this case, our function is going to be y equals the initial value, $30,000, depreciating at 4.5%. And remember, 4.5 is not our decay rate. We need to take 100% and subtract 4.5% to figure out that the car retains its value, retains 95.5% of its value year after year. And when we convert this to a decimal, we're going to slide that decimal point 2 places to the left, which means my decay factor is 0.955. So every year the car retains this much of its value raised to the x power. And in this case, we're figuring out how much it's worth 10 years later. So we're going to substitute x for 10. I can plug this into my calculator here. $30,000, 0.955 raised to the 10th is 18,930. 0.19, I'm going to round. Okay, so after 10 years, the car is worth $18,930. Number two says, if you deposit $4,000 into a savings account that offers 6% interest compounded weekly, how much money will be in the account after 18 years? So example 2 deals with money. It deals with a savings account, and it also shows you this clue word here, compounding. So that's a good indication that we're figuring out compound interest here. And because it's compounding weekly, I'm going to use the standard compound interest formula, which is going to be the amount in the account after 18 years will be the principal times 1 plus the rate, which is 6% converted to a decimal is 0.06. A lot of you made that mistake in your quiz, so double check that when you convert a percent to a decimal, that you're sliding the decimal point 2 places over n, which is the number of times that it's compounding in a year. And if it compounds weekly, the number of weeks in a year is 52. All raised to the nt, so that's going to be 52 times 18. Punch this into a calculator. $11,771.39. So think of it this way. If your parents put money in a savings account when you were born, then by the time you're 18, they put $4,000 into account. By the time you're 18, you'd have $11,700 in that account. However, in the real world, no banks are paying that much interest. It's more like 2% right now. Last one. Number 3, the value of a treasury bond pays 4.5% interest compounded continuously. What will it be worth in 10 years? So once again, we see the words compound to let us know compound interest, and we see the word continuously telling us that we need to use that Euler's constant formula, where the amount after time is 10 years, is going to be the principal. I didn't give you a value. Let's say worth $5,000, sorry. And because it's continuously, we use that base E, Euler's constant, raised to the r times t. R in this case is 0.045 times t, which is 10. Put that into my calculator here, 5,000. There's two options for your E. The one on the right hand side, you could use that with a caret, or just in case you haven't figured this out yet, on the left hand side it actually gives you e to the x right above ln. So if I hit second ln, it gives me e and the caret all at once. Okay, 7841.56. 7,841 and 56 cents.